Hi guys, my name is Mitesh and welcome to my YouTube channel. In this video, I will be discussing about an advanced C++ topic. The topic name is Recursive Template Instantiation. As the name suggests, Recursive Template Instantiation, it contains both template and recursion. So before we discuss about the main topic, we must know about what is template and how it's work. We also we also should know about what is recursion and how it's work. So we will first discuss those two topics and then we'll go to the main topic. So let's start the video. Let's first discuss about the template in C++. So consider this example, add example. We have a add method that accept two integer parameter, num1 and num2, and it perform addition and return the value. Similarly, we have one more add method that accept double data type, and it also does the same addition of two double data type and it return. So consider tomorrow I need one more add method that I want one more operation that accepts one float and one integer. Then I can write here one more add method and do some of this addition operation and return it. So instead of writing individual method for different data type, C++ provide facilities to create a single method, to create only one method that works for all the data types. Okay, so consider this template method. Here we are creating add addition method of the template. So template type name t and add. This is add method and we are passing template parameter. We are doing the same addition operation. Now when we use this add function in the main or anywhere else, we need to pass data type integer. That means I am instructing compiler to I am passing integer argument here, integer 5 and 10. And what compiler in the background do? Compiler go here, it create instance of this template function for this integer data type. It perform calculation and return here. It calculate and return here. Okay, now again I use add with the float. Okay, float data type, and I pass argument. Compiler come here, compiler go here in the template function. It create instance of this float argument, float data type. Okay, and it do operation, it perform operation and return the value here. Now again consider if I have one more add call, add integer 10 and 20, compiler will not create new instance. Instead of that, compiler has already created instance for this integer. It reuse that instance and do this calculation and return. So for each individual data type, compiler create instance of this template function and use for the calculation or to do some action. So in a high level, template allow us to create a generic class or function that works on different data types. So this is all about the template. Remember this concept. Internally it create an instance. That is important thing. Now what is a recursion? Recursion is a technique. That means recursion is a technique that it is a function that call itself. That means I am writing a function that call itself. So recursion is a technique where a function call itself to solve a problem in a smaller step. That means consider this example. I need a factorial of 5. Okay, and I am here writing recursion function. So this is a recursion function of the factorial, and I am calling again this factorial method, recursive method. So okay, before we discuss about this, we can also read about this. So when we create a recursion function, we need to take care of two things. first thing is base case. That means we should know when, at what point we need to stop. If we forgot to write a base case, the function call itself infinitely, which can create a problem, right? So we also need to consider base case where we need to stop it to prevent the infinite loop, and we also need to write a recursive case. That means function call itself. So if we see it here, factorial method, this is a base case. When we have n is equal to 0, then we are stopping here, return 1. When n is not equal to 0, then we are calling our own function with different value here, factorial n minus 1 here. We are calling ourselves only. We are calling this function, factorial calling itself only, correct? This is the recursion. This is the basic of the recursion. So when we pass 5, it will come here 5, then factorial 5 minus 1, 4, in again call it, then 4, factorial 3, again call it. When we have a factorial 0 here, n is equal to 0 and return 1, and everything will be solved like this. Okay, so this is all about the recursion. Now we know what is template, what is recursion at very high level. Now we can start our main topic, recursive template instantiation, because it is a mixture of both. Now, what is recursive template instantiation? So recursive template instantiation is a technique. It is a technique in C++ template metaprogramming. So when we write recursive template instantiation class, so that class perform recursive computation at compile time, not at the runtime. This is a main feature of this recursive template instantiation. I explain what is happening. So recursive template instantiation is a technique in C++ template metaprogramming that enables compile time computation. That means when we write recursive template instantiation code, it will execute at compile time but not runtime. So here the second statement is, unlike traditional runtime recursion, traditional means like this one. Unlike traditional runtime recursion, where function calls are executed during program execution, recursive template instantiation unfold entirely at compile time. Okay, so everything done, this such mechanism is done in compile time in case of recursive template instantiation. I will see in the next slide what is happening. Now when we call each time recursively, in the background compiler create instance of each value. Remember I told you, for each here data type compiler create instance. Similarly here, on each value compiler create instance, and that is happening only through the compile time, only compile time. So each unique template argument here, each unique template argument result in the compile generating a new instance of the class. Consider I am passing factorial 5. It comes here factorial 5, here 5, factorial 5 minus 4, 1. It comes here. So now when I pass 4 here, 5 minus 1, 4, that also, at that time also compiler create instance. When I pass again 3, at that time compiler also create instance. So each time we have a new value, compiler create instance. Not even new value, when existing value we have same value, then also it will create instance, new instance. So when we write this recursive template instantiation, we also need to remember base case to prevent infinite recursion. So this is a base case. This is sometimes called a specialization case. So when we have a 0, factorial of 0, we are directly returning 1. This is a base case, that means AND case. Okay, and recursive case, this is a recursive case. So these two cases, this is same as we discussed here, base case and recursive case in the recursion. And important note here is everything happening through the compile time, not runtime. This is a key lesson for this recursive template instantiation. Now consider this example, factorial example. We are calling here factorial 5. We are passing argument 5. It comes here 5, value 5 here into 4. 5 minus 1, 4 here, 5 into 4. Now when we pass here to here, compiler in the background, it create instance, as I mentioned earlier also. When we pass 4 here, 4 minus 5, 1, 3, again it call itself. Whenever it calls itself, compiler in the background, it create instance of that value. Instance of here 4, then 3, then 2, then 1, then 0. When it comes to 0, it comes here. It return 1. So each time when we pass value, compiler create instance of that value, of that template class. And the final result will be the same, 5, 4, 3, 2, 1. Okay. So there is a basic difference we can identify here between recursion template instantiation and regular recursion function. Let's discuss that one also. So here template recursion versus runtime recursion. Template recursion happen during compile time. As I discussed, everything happen, all these things happen during compile time, while normal recursion works during runtime. So in terms of overhead, for runtime recursion, we get overhead in runtime, but in template recursion, we do not have any overhead during runtime because everything done through the compile time only. Now, whatever the error we have, we can detect through the runtime, compile time, sorry, through the compile time only in case of template recursion. While in case of regular recursion, it detects during runtime. Now, template recursion has some limitation because when we use this recursive template instantiation kind of things, we generally know this value when we write the code. That means I must know when I use this recursive template instantiation 5 before I execute this code, I should know what I need to pass here. I cannot get from the user. Here I cannot write C in and get from the user and pass this. This is not done. I need to know before. Okay, that is a limitation. While in the runtime recursion, that means normal recursion, this is not a limitation. We can ask from the user and we can use this. Okay, this is so. While working with the recursive template instantiation or template recursion, we have a problem also. This functionality, this feature has a problem also. Let's discuss that problem. So the first problem is everything done through the compile time. That is one good condition, but bad condition is for each time. Consider as I explained you, for each time during the compilation, we are creating instance of recursive template instantiation, this class instance. Every time we are creating instance. Consider I have here 1000, so it create 1000 time instance right here, and all these things happened during compilation. That means while compiling, when I pass this 1000, it create in the background 1000 instances, and it takes lot of time in the background. Compiler has to create instant, it has to resolve this expression and then return, then again it need to call it. So 1000 times it has to done, and each and every time it create instance, and for each instance we need to allocate some memory. Okay, so that means it require higher memory, it increase the compilation time also. Okay, that is not good when we use recursive template instantiation because it creates too many instances. That means when we have a deeper recursion, more template instantiation creation, and that leads to increase in compilation time, higher memory usage. And one more thing, maybe in the latest compiler, some compiler, what they do, they put some threshold value for the recursion. Consider I have compiler, and by default that compiler has some default value of 500. That means if I cross more than 500 recursion, it throw error. Okay, so that also, while compiling we can get error also, potential compiler recursion depth limit. That means we have a limitation also, compiler can put. It is depend on the compiler also. The compiler, if compiler has some threshold value that it is not ready to call recursive after 500 calls, then it can throw error. If I passed 1000 here, that is also problem. Okay, so all this problem we have with the recursive template instantiation. Now if you are working with latest C++, there is a feature called constexpr function here, constexpr function, that also work mainly in the compile time also. It is also work in the runtime also, but if we pass value compile time, it 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 will resolve all the expression through the during the compilation only. It will not go to runtime. Let's see discussion about this const express function. So const express function that is introduced after during C++11 and later is a better alternative const express function which allows compile time computation without excessive template expression. That means here we have a limitation. When we use recursive template instantiation, we have a limitation because it create too many instances to work to resolve the to compile the or all the expression from top to bottom. But when we use const express, here the same code I have, const express function, factorial function, this is a base condition, and n into factorial n minus 1. Now one good thing is, if I am passing 5 here, okay, and this is const expression, so this is also happening through the compile time. But the good thing is, in the background, it will not create too many instances. In case of recursive template instantiation, it creates too many instances, but here we do not have too many instances, and also it works compile time. That is a good thing when, in case if we use const express function for this factorial class, or if we have any recursion function, factorial function here. If we are using recursive function, uh, possible to use const express if you are using C++11, because if you pass this direct value compile time, then it will run execute compile time. This can also work runtime also. Consider if I ask from the user that what value you want for the factorial, at that time this behavior change to the runtime. So it works for compile time and runtime. This is a good thing for us, and this is a better approach instead of using this recursive template instantiation. I hope you understand all the content of the video regarding what is recursive template instantiation, and what are the problem with the recursive template instantiation, and what is const expression function for the recursive functions. If you find this video helpful, please like, subscribe my channel. Thank you.